start recording now. It's kind of weird. So I'm sorry that we're late. What was that?
For like this quarantine break, I left my notebook in your class to get graded, and it's still at class. It's not with me.
Well, that's not good. It's going to be there for a paper, and then you can just take pictures and send them to me. But I wouldn't take paper and fold it in half like we did. I think that was Gabriella talking. I couldn't hear because it was kind of broken up. Whoever said that they left their notebook, go ahead and do it on paper, and then we can you can send it to me. But do it in such a way so you can attach it there later. Okay. All right. So for those of you who just are watching the video, this is where we started. Delgado's fault. We didn't report from the beginning. We divided by sign. What would we get?
Tangent.
We would get sine over sine would be
1.
1. Sine over sine would be 1. And what about cosine over sine?
Cotangent.
That would give me cotangent, right? So that would give me cotangent. So your major lag over here. Oh, crazy. So 1 plus cotangent. Now I have 1 over sine, which would give me
Cos.
over here. I would have 1 over. I am getting broken up voices, so don't be upset if I don't recognize your voice, because I am getting some. That's what I'm getting over here. So sorry. I try to call you by name when I recognize your voice, but I won't recognize anybody's now. All right. So even and odd functions. These are our fundamental identities. Which ones are even and which one are odd identities, right? So let's look at, if we recall, a function is even if f of negative x equals. Anybody remember that?
That would be f of x.
Very good, f of x. Good, Michael. And then a function is odd, right? If f of f of negative x equals
Negative f of x.
negative f of x. Good job, Cheyenne. Okay. And if it's neither one of those, then we say it's neither, right? So of the ones above, which ones would be even? Any ideas? You can tell me one.
Cosine. Cosine it. Secant.
Secant would be one. And what would be the other one?
Cosine.
Cosecant. Was that you, Mayara? I'm making weird. Blah, 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 blah. So I'm going to go with cosecant. Yes, those are our even ones. Which ones are our odd ones? So that means we're going to.
All other ones. All the other ones that aren't even.
Good job, Cheyenne. All the other ones. All the other ones are going to be odd functions, right? All the other ones are going to be odd functions. Okay. So I'll give you a minute to write that down for those of you who are writing. And you might want to make little arrows and point even and odd, however you want to do it. I'm going to draw while you guys are writing. I see some people writing. I'm going to say these are the even ones.
Mr. Delgado, check your participants.
Thank you. Thank you very much, Ms. Sally. Appreciate it. I had somebody here in the waiting room. We're looking out, just Sally. All right, everybody good? Yes, no, maybe so.
Yes.
All right, I see a bunch of thumbs up, so I'm gonna move on. So using our fundamental identities to verify other identities. So how do we verify, prove, or tell if other identities are true using algebra and our fundamental trig identity? So to verify an identity, we show that one side of the identity can be simplified so that it is identical to the other side. And we're going to do this with the other side, but there are times where we're going to have to work both sides independently and then see where they meet. You know, we can get to something where you have the left side equaling the right side. We'll see that in example 4. So first, each side of the equation is manipulated independently, like, and hopefully we end up with the other side. We're going to start with the complicated expression first. You start off with the harder one and hopefully end up with the other side of the equation. And on one or more on the complicated side, and you try to get it to a form that you can, when they're both difficult on both sides, what you do is you try to reduce them into something that looks doable on both sides. Okay? So let's see what this looks like. What are you talking about, Delgado? That makes no sense at all. So copy this. This is example 1. There we go. So example 1, to verify an identity. So go ahead and copy that. Example 1, which is cosecant x times the tangent of x equals this to the right. The left, right? And we're probably not as familiar yet with cosecant and secant. Again, the more you do these, the easier they become. They start to become second nature. But if you don't do any, you don't get any better at it. In My Math Lab, you'll do plenty, so make sure that you're doing your My Math Lab for this section. Like I told you, what we have left for this year is not difficult. It's just new. None of this stuff is difficult. You're going to like it. It's going to feel a lot like Algebra 1, just on a different level. Okay, that's all it feels like. Algebra 1 just on a different level because you have to learn new little bits and pieces. Okay, so let's see how we solve this. So we read that the left side looks more difficult, so we're going to work with the left side and hopefully we'll end up with the right side, okay? So the first thing that I noticed is I have cosecant, right? Sines and cosines. Cosecant is?
1 over sine of x.
Very good. Whoever that was, I heard that kind of a male and a female be giggling the whole entire class because it's funny. All right, so this is 1 over sine of x, and tangent of x is what?
Sine of x over
cosine.
Very good. Was that Cheyenne? That sounded like Cheyenne. If it wasn't, I'm sorry. All right, let's see. Sine over cosine. Can you see what's going to happen now, right? Now I can take both of these expressions and replace fractions. You're going to see what happens. It's so exciting. It's so cool. See, now when I rewrite it with those in there. Whoa, math is so cool, dude. What happens to the signs? Melody Perez, known as aka Haley. So they divide and they cancel, right? They cancel each other out. And now what do we end up with?
1 over cosine of x.
Good job, Roberta. 1 over cosine of x, right? We end up with 1 over cosine of x, also known as what?
of x.
Secant.
Good job. So secant of x, correct, right? And then we verified the identity. Got the idea? You see how this works? It's kind of like a puzzle. Don't fall, Devin. You're defying gravity. How do you do that? It's not working for me. All right, everybody good? Thumbs up, thumbs down. We move on. Yes, no, yes. Okay, we move on. Example 2, using factoring. So go ahead and copy the problem, example 2. Then you have sine of x minus sine of x cosine squared of x equals sine cubed of x, right? Which side looks easier, left or right?
The right side.
Right looks much easier, right? So we're going to work with the more difficult one, which is the to the left, to the left, to the left, to the left, right? So we're going to work with the left. So can you see what happens already? Anybody got some ideas as to how to solve this?
The signs cancel. Maybe.
The signs are going to get
Factored out.
very good. The signs are going to get factored out. Factor the sine of x from both of the expressions, right? We factor the sine of x. So once we factor sine of x, everybody got that? Write it down. And then what happens? 1 minus cosine squared of x. Well, I don't remember seeing that. I remember seeing a 1 plus the cotangent or something like that, but I don't remember seeing that one, right? However, I do remember one of my Pythagorean identities was what? What was one of my Pythagorean identities? The first one that we learned.
Oh. Sine squared of x plus cosine squared of x equals 1.
There you go. Good job, Melody, aka Haley, right? So now if I take this, right, and I subtract the cosine squared of x from both sides, right, I end up with what?
Sine squared.
Very good. I end up with sine squared of x. Good evening, right? Sine squared of x is equal to 1 minus cosine squared of x, right? Well, guess what? Now I can see those two. I can replace that with sine squared of x and put it right in there, right? Got the idea? So now all I need to do now is multiply. What's sine of x times sine squared of x? What's 17 times
Sine
17 squared?
17.
Sine cubed, right? Because it would be 17 cubed, which means this is sine cubed, right? All we're doing is multiplying, right? Adding another term. And that's what we were trying to end up with. We were trying to end up with sine cubed. Got the idea? So this is kind of what they call an algebraic proof. They're calling it verifying that an identity is true. It's really an algebraic proof. Give you a moment to finish writing. Everybody good? Just know. 2 more examples. Okay? Okay, we move on. We good? Jess? Thumbs up or thumbs down if you're Devin, right? There you go. There you go. That's it. Good job. Devin, that looks funny. All right. So now, verify the identity. Ooh, yeah. Now they're getting interesting, right? Yeah, this looks like fun. Combining fractional expressions to verify the identity. This is example 3. All right. So again, which side looks more challenging, the left or the right?
The left.
The left definitely looks a lot more challenging. It's got fractions, it got signs, it's got a bunch of stuff on it, right? So we're going to work because we're cool like that, we're going to work with the tough one. The other one looks way too easy. So that's what we're trying to end up with, right? So this one looks definitely more challenging. So let's work with the fun one, which is the left one, right? So I'm going to rewrite it. And if I were adding fractions, the first thing I would want to do is have a what?
Common denominator.
Very good. I got to find a common denominator. In this case, what's my common denominator going to be? If one was a 3 and the other one was a 7, what would I do?
Find the word for it right now, but we would have to like multiply them so they
You have to multiply them. You forgot what it's called. It's called the least common multiple of the denominators, or the least common denominator might have been the way you learned it, or LCD for short, because we're all mathematicians and we don't like to write, right? So we got to find the LCD of those two denominators, right? So if it was a 3 and a 7, we just multiply them together, right? One person in the waiting room, how do I add them? Okay, so all I would have to do here is find the least common denominator, which is what? And this, I don't know. Can somebody help me out?
Why don't we just multiply it by each other, like here now too?
Very good. Sounded funny to me, but it was very good. You multiply them together. So it's sine of x times the quantity 1 plus cosine of x. That's the least common denominator. So that means I have to multiply both of these, right? By the corresponding parts, right? So let's take this one, the one on the, I guess it's pointing to the one on the right first. What would I have to multiply the one on the right for? Oh no, I gotta change that arrow, that looks funny. Okay, so the one on the left, what's missing? The sine of x, right? So I have to multiply by sine of x, right? Notice it has a sine of x. I have to multiply by the sine of x, right? The one on the right is the one that I'm multiplying by 1 plus cosine of x. Yes, no, maybe so, got it? So on the right, I have to take that 1 plus cosine of x and multiply by 1 plus cosine of x. Everybody okay with that step? Because that's the hard step. From here, it's easy. From here, the rest is algebra. Okay? Gotta change that arrow. Those arrows are weird. Okay, so on the left, what do I end up with? On the left expression, sine of x times the sine of x is going to give me?
Sine squared of x.
Sine squared of x. Good job, Madeline. Okay? And on the right, what do I end up with?
On the left, wouldn't it be 1 plus cosine squared of x? Or no?
1 plus 2 cosine of x plus cosine squared of x.
Good, Madeline. You were close, Haley. But remember, right, you have to use FOIL, right? You have to use FOIL. Remember, the quick way is a plus b squared is equal to a squared plus 2ab plus b squared, where a is 1 and b in this case is cosine of x, right? Plus cosine squared of x. Everybody with me? You good? Yeah? Delgado, well, this isn't getting any easier. It looks bigger. We start off with something smaller. Now we got a bunch of stuff, right? No tricks. That's the same thing we had before, right? I just recopied it. Add the numerator. So that means we have the same. That was the whole point, trying to get it under the same denominator. So now it's under the same denominator, right? So this would be your next step, right? And from here, I start to think about, are there things that I can group together? What do you notice that you have? I'll give you a hint. It has to do with the Pythagorean identity. Very good. Sine squared. Was that what you said, Gisele? Sine squared of x plus cosine squared of x? There you go. So if we group those two together, right? If we group those two together, we get something that looks like this, right? 2. Sine squared of x plus cosine squared of x is equal to 1. So I can replace that sine squared of x plus cosine squared of x with a 1, right? I can replace that part with a 1, right? So I'm there, starting to look cleaner, right? So now I can say that 1 plus 1 is 2, right? So 1 plus 1 is 2. So I have 2 plus 2 cosine of x. Now we're talking. Give you a minute to write that down. Everybody got it? Yes, no, maybe so. Okay. So now we're here. What can I do now? Factor out the 2 in the numerator. When I factor out the 2, I get 2 times 1 plus cosine of x over sine of x over 1 plus cosine of x. Haven't had any coffee. I'm a little wound up from coffee earlier. All right, so cancel the 1 plus cosine of x's, right? Cancel the 1 plus cosine of x's. And now I have 2 over sine of x. If I take out the 2 from that expression, right? Factor out the constant term. I have 2 times 1 over sine of x. And 1 over sine of x we know is what?
Cosecant x.
Very good. Cosecant of x. Does that make sense?
It just seems to take time.
It takes time. Exactly. Good, Nicole. It just seems to take time and it is new. So this is new out learning how to apply them with these new fundamental identities that you're learning. Okay. So it's not difficult. It requires practice, and the more you practice, the easier they get. And like I told you, a lot of this to me is just puzzles. This change. I don't like problems, but I do love puzzles. I'll show you a puzzle that I did. I'll post it so you guys can see. This is the hardest puzzle I've ever done in my entire life. When I was younger, I did a lot of puzzles. I did up to, with my uncle, he's a big puzzle guy. My uncle did one time a 10,000 piece puzzle, which was crazy. But I used to work on puzzles with him that were 2,000 and 3,000 pieces. But the one I just did, which was 1,000 pieces, is crazy. Has anybody ever heard of photo mosaics? We'll never buy those puzzles. The puzzles for those are crazy. I just finished.
I have 2 of them.
You have 2 of them? How many pieces?
I think they're each 2,000 pieces.
Oh my Lord, you're going to be there for a while. I did the one that was 1,000. It took me like 3 days. And I've done 1,000-piece puzzles before. This was far harder than anything I've ever done. Far harder than any 3,000-piece puzzle I've ever done. This was just plain out hard. All right. Oh, that looks easy. And then I want you to zoom in. And when you zoom in, you're going to go, that is crazy. Because each puzzle piece is a picture from a Disney film. Say hello.
Hi. Let me show you the puzzle.
What, the picture? I'll post it. Don't interrupt my class, lady. All right. Oh, that's right. I forgot I have a picture here. Yeah. There's Alexander. Alexander wants to say hello.
Hi. Ignore him. He's
Imagine doing.
Of it. It's really cool, but
like a 3 day.
crazy. We took 3 days doing that. It was nuts. 4 o'clock in the morning, my daughter woke up and then she wanted to work on it. All right, so this is going to be a little different. Which side looks easier here? Left or right? Which one looks easier? I heard right. The right looked easier to me too. The left looked harder because it had fractions in it. But I wouldn't call either side easy, correct? So this is the type that you're gonna have to work with both sides and see. Hopefully you'll end up with somewhere in the middle that will, I checked this, Isabella's here. So hopefully you end up somewhere in the middle where it'll get easier, okay? Or you'll get something that'll equal something else. So let's see how we do this one. We're gonna start off with the left side since that's the one that looks the more challenging one, right? So let's start off with the left side. Whoop, there we go. So we're starting off with this side, okay? If you just got in the room, go ahead and copy the problem. And then we will, again, like I said, I have office hours after this. So if you missed the lesson and you can stay afterwards, well, you're welcome to stay because I still have another hour. So I'll go through the lesson again if you, okay? And I need to record the beginning of the lesson, right? Because I forgot to record from the beginning. All right, we're good? Just no, maybe so? All right, so what can we do with this side? Let's see. We have 2 fractions that are being added. So we need to find the what?
Least common denominator.
Very good. Least common denominator. Good job, Haley. Okay. So we find the least common denominator, which is going to be what? Instead of x, they're using theta here. 1 plus sine theta times 1 minus sine theta, right? Is that what you said? Okay. So I multiply times 1 minus the sine of theta on the first expression. But whatever I do to the denominator, I have to do to the numerator, right? And I'm going to do the same thing on the other side. The other side, I have to multiply by 1 plus sine of theta. So I'm going to multiply both numerator and denominator by 1 plus sine of theta. Okay? Got it? Yes, no, maybe so. And now I can go ahead and distribute. It's going to be pretty easy because I'm multiplying times 1, so I can just rewrite the top pretty much, right? My denominator is 1 plus sine theta, 1 minus sine theta, and now my numerator, I can add them together, right? I distribute the 1s, and I end up with 1 minus sine plus 1 minus sine theta plus 1 plus sine theta. What's going to happen to those sine thetas?
They're gonna cancel out.
Very good. They're going to cancel each other out. Good job, Shelly. They're going to cancel each other out. Those sine thetas are going to cancel each other out. And now I end up with 1 plus 1. We can do that, right? That one's easy. 1 plus 1 is
2.
2. All right, so we got that. And now we multiply the factors in the denominator. So if you recall, that's an a plus b, a minus b, right? So it should be the first one squared minus the second one squared. So it's going to give me what?
1 minus sine squared theta.
Very good. 1 minus sine squared theta. Okay. You got it, just no, maybe so. Okay. So now we work with the left side. That's where we ended up on the left side with 2 over 1 minus sine squared theta. That looks pretty good, right? We could probably simplify it a little bit more. I don't know that we could because we got sine squared. So maybe we can simplify it a little bit more. But for right now, that's good. That looks a lot better than it did at the beginning. The question is, can we get the other side to look like that, right? If we can get it to equal the same thing, then we verified our identity. If we can't, we got a problem, right? So let's try the other side. So we're going to start off with 2 plus 2 tangent square theta, right? And what do you notice that you can do with those? Write that down. So what can I do to those?
You can change the tangent squared theta to, it's, oh my God, what's it called? I think the sine squared theta over cosine squared theta.
I could do that, but I see some.
Factor out the 2.
The 2's, right? Those 2's. So what can I do with those 2's? I can do what? Factor, right? So I'm going to factor the 2's out first. And by the way, there's more than one way to do this, right? There's more than one way to do this, right? I actually, they're doing it like you did it, Nicole, I think. So tangent is sine of theta over cosine of theta. And then tangent square theta is equal to sine squared over cosine squared. So they're doing it your way, Nicole, right? So they did that. So let's do it your way. Now what? That I've got that. Everybody got that? What else can I do? What's your least common denominator going to be in this case? What's the denominator on yours in the second expression? The first expression is 2. The second expression is 2 times sine squared theta over cosine theta in the second expression.
Cosine squared.
Cosine squared theta, right? So that means I need to put a cosine squared theta in the first expression, right? But I can't just multiply cosine squared theta, put an operation, however, that I am allowed to do, right? Just because I feel like it, right? I can always do what? I can always multiply by what number? Just because I feel like it.
1.
1. 1 does nothing to it, right? 1 does nothing to my expression, right? So which name is going to help me out here?
I'm thinking cosine squared theta over cosine squared theta.
Way to go, Haley. Woo, 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 woo. Go, Haley. So if I multiply that by cosine squared theta over cosine squared theta, right? Now I have a common denominator, right? And my common denominator is going to be cosine squared theta. Everybody got that down? So now I can write them both under the same denominator, and now I add the numerators. Now I can go ahead and factor, right? If I would have factored right from the beginning, I may or may not have ended up with the other expression. I guess Nicole was being a little bit more careful than I was. She was paying attention to the previous result that she got. I didn't write it down. I should have written it up here somewhere. So then I had it, see what I was looking for. Good eye, Nicole. Good job, Giselle and Haley. You guys are doing a great job. So now that I have this, now I can factor, right? Yes? Let's see. Now we can factor out the 2, right? So factor out the 2, what do you end up with?
Cosine squared of theta plus sine squared of theta.
Very good. Cosine squared theta plus sine squared theta, right? You factored out the 2, you end up with cosine squared theta plus sine squared theta, which is equal to?
1.
1. Good, Devin. Okay. You end up with a 1, right? So that's a 1 in the numerator over 1 times 2, which is a 2, right? Over cosine squared theta. And now what? We're almost there, because remember, what was your other expression? 2 over, not cosine squared theta, but what?
1 minus sine squared of theta.
1 minus sine squared theta. Well, guess what? If I take this, right, and I subtract sine squared from both sides, right, I end up with cosine squared theta equal to?
1 minus sine squared of theta.
There you go, good, Nicole. So now I have 2 over 1 minus sine squared theta. And I know I've seen that before somewhere, right?
The expression on the left.
The expression on the left, right? So now, by doing verify, right? The left side gave us 2 over 1 minus sine squared theta. The right side also gave us 2 over 1 minus sine squared theta. So now we can say that we verified the both sides of the equation are equal. Got the idea? This should give you enough to get started with your My Math Lab and other stuff. Again, this does not replace you guys going in and reading the section for 5.1 and taking notes on 5.1. One of the big questions was, are we going to have to do notes for all the sections? I would rather not. And you can check it before you actually, whenever you do the quizzes. It's not difficult. But if I see grades start dropping, then I'll start to require the notes to be taken. I think you guys do a good job of notes overall. I'm very happy and very proud of the work you guys have done all year long with your notes. So hopefully that is something you can use in the future for your other classes. So again, this does not replace you reading the section and taking notes from the section, because this is just part of it, right? When you read and you take notes, you'll see that there are stuff that we did not cover within our time here. Okay, so make sure that you read it, find out what you got and what you need to add. Another question that came up is, Mr. Delgado, what if we wanted to meet with you through Zoom? I am usually on Zoom from 10:30 to 1:30. So you're in this space. So if you want to talk to me, or if you have a problem that you can't understand or you can't solve, then just go to 11:30 to 12:30. But I'm here for an hour before and an hour after. And all you do is you see me hanging out here. Sometimes, I'll put a note on the board that says I'll be back in 5 minutes. But you use the same Zoom code to log back in, just if you have questions or you don't know how to do a problem. Any other questions on what we did today? Okay, if you would like to stay and go over the beginning part of the lesson because you came in a little late, and just stay, everybody else, and look forward to seeing you next week at this time. Or if you want to meet before, I'll be here. If you miss my face, I'll be here. All right. Have a good day.
Adios.
Bye. Have a good day. Hey, bye, so I can see your face before you leave.
Bye.
Bye. Bye.
Bye,
Bye,
Mr.
Brenda.
Mr. Delgado,
Yes, Gabriel.
is the My Math Lab due on Friday still, or is it going to be due on Sunday now?
Scheduled just to
Is it
have
still
one
due on
deadline
Friday?
all the time. It's going to be,
Oh, okay.
the My Math Lab is going to be due on your
Okay.
deadline. Again, I haven't been very as much of a stickler about deadlines. You need to have a deadline just to keep yourself organized. And that's something that we'll probably talk about in our meeting today after school to see if we do. I think it's the best idea ever. Just kind of everybody has the same deadline, so then there's no confusion among you guys. And then that way it forces you to have your own schedule. You guys can make your own schedule and decide when you want to work on things. I think creating your own schedule is a much better use of your time now that you're home, because then that way it gives you time to do what you want to do, and it gives you time to do what you have to do, and it gives you the flexibility to schedule it yourself. So I think that's a better idea, but I don't know how the teachers will receive it. Ms. Sakasa mentioned it, and I thought it was a great idea, so I just adopted it. But we'll see what happens today at our meeting. I'll keep you guys posted. I'll put a post on Classroom as to what was decided when this discussion came up.
Mr. Delgado.
Yes.
Okay. So once a week, we're going to have a My Math Lab due. And that's the only assignments you're going to give, right?
The only assignment I am giving is the My Math Lab and your assessment. You're going to have a My Math Lab, one section per week. We really need to cover a lot of stuff. So if you're going on to calculus, we're going to be missing some material. I will let Ms. Goddard know what we covered and what we didn't cover, so that she's aware for next calculus. We simply don't have the time nor the flexibility to cover that stuff. So she's going to have to deal with that next year. But I want to make sure at least we get through the trig part, because that's really important for calculus. We got to get through that part. So I'll put the sections that I thought were most important, and it wouldn't be something that would be too overwhelming for anybody. I know these times are tough. It's tough to be at home trying to do this from home. So I didn't want to add too much more. As long as we covered trig, I think we're going to be fine, and Ms. Goddard can fill in the blanks next year. So you only have one assignment per week, which is the My Math Lab
And the quizzes.
and the quizzes. The quizzes will
And
be
that's
on
the
that
only thing I'm
day.
going to worry about in class, since I already attended your Zoom meeting.
Yeah, you just covered it, Alexander. So you're done with that.
So all I got to worry about you is one of My Math Lab a week and the quizzes when you send the email, and that's it, right?
Right. If there is something additional, I will post it. But in general, that's all that we have left. I do not want to give additional assignments. Everything else that I will assign that I want you to do would be for extra credit. In other words, it won't impact your grade. So there are additional things that I wanted to do. One of them was a project related to COVID-19, but because of the feedback we've gotten from our faculty meeting, I don't know that I want to do it, because some people might get stressed out by it. I wanted to do a really cool project on that, and I wanted to do some learning on Teams, but I think people are kind of stressed out about it, and I don't know that all teachers are being as receptive as they need to be about the situation.
Yeah.
So I don't want to push too far. You know that I can push, right? I push pretty hard. I'm
Yeah.
taking the opposite approach on this because it's just tough. I mean, it's just a tough situation for everybody.
I feel you. Well, thank you, mister. Have a
All right,
good day.
Alex. All right, you too. All right, so the people that are here, let's go back to the beginning of time. I've got Asiana and Alejandro and Cheyenne. Go back to the beginning of time. You guys weren't here at the beginning? Hello, anybody? Cheyenne?
I was. I'm just getting extra, like, because
Give me
I got
five-
confused a couple times.
Okay, so let's go through. Anybody that needs me to go right from the beginning? Alciano or Alejandro? I know see you. I know hear you. Alejandro?
Yeah, I wasn't here for the beginning.
Okay, so you want me to start at example 1 or right from the beginning? Right from the beginning. We'll go through this real quick. Because you are very, very smart. You go right from the beginning and we talk about this. Have your phone ready, Alejandro, and that way you can just take pictures of the notes and then you can fill them in later.
Okay.
So this is verifying trigonometric identities. So we're going to take trigonometric identities and use them to solve for algebra. Cheyenne, if you want to just listen or if you want to take a little break and then go from there. So this is, oh, let me stop the recording here. I forgot that we're done. Here.